Hello students, good morning all. Welcome to our Sarva Siksha Abhiyan online classes. So, due to these online classes, we have completed our syllabus as per given in the month schedule in our textbooks. So, we don't need to worry about the syllabus and its completion after reopening of the schools. Okay, students. So you just focus on the online classes and note everything in your notebooks so that you can easily recognize or easily revision the concepts of the textbook when schools are reopened. Okay, students? Okay. Already you know myself, B. Radha Devi, working as a physical science teacher at KGBV, Kallur. So today we are going to discuss about the next lesson, that is atoms and molecules, and it is the first part of the lesson. Okay, students? Okay, so first of all, to discuss about the atoms and molecules, we have to know. So, to discuss about the atoms and molecules, we have to know the key points what are there in this lesson. Okay, for that we have to note down the key points. Okay, and these are the key points which will appear to us in this lesson. So, let us make a note in your notebooks. Introduction. First one is the introduction. Next, law of conservation of mass. Law of constant proportion. Dalton's atomic theory and the laws of chemical combination. Atoms. We are going to discuss about the definition of atoms, molecules, elements and compounds. We are going to discuss about these in deeply. Okay, then what are the symbols we have giving to the elements, that one also we have to learn in this chapter. Now valency, ions, what are the formulas given to the compounds or molecules, that one also we will learn in this chapter. Okay, students? Now crisscross method. What is this method and what is the useful of this method, and we have to learn. Then what are atomic mass, molecular mass, and what are the formulas, unit mass are there, the mole concept and molar mass. These are the key points which we'll discuss in this lesson clearly and deeply. Okay, and this is very useful to you for your higher classes. So be concentrate on this lesson. Okay, students? Okay, first of all, to discuss about this lesson, we have to recapitulate. We have to recapitulate the previous lesson which were discussed by us in the last month. What is that lesson? Or what about the lesson is there to discuss? Yes, matter. We discuss about the matter is pure. Already we discussed this one in the last month. So now we have to just recapitulate that concept to understand, because this is the connectivity to the present video which we are discussing now. So let us recapitulate the previous class. So first is, what is matter? Already we know that matter is nothing but which has a space and a mass in the universe. Okay students, already in the last class we discussed about this one. What is matter? What it consists of, means how they are made. All are discussed in the previous class. So if you observe this picture, you can easily tell what is that matter. Means around us so many types of objects are there, substances are there, some bodies are there. So all are considered to be matter. Okay, now here if you observe in the picture, computer, coffee, butterfly, everything, plant, cat, even ourselves, means human beings also considered as matter, because we are occupying some space and mass. We have some mass and we are occupying some space in the universe. So we are also considered as matter. Okay students. Now, we are also discussing in the previous chapter how many types of states are there in these matter. So, how many types means? Three types: solid, liquid and gas. So, these are the types are there in the matter. And we are also discussed about the types of mixtures or solutions related to this matter. And how the mixtures are separated with different techniques are also learned in the previous classes. Okay, so all are things related to this matter. Now I'm asking question to you. I'm asking question to you that how the matter is made. You simply says that matter is made up of particles. Matter is made up of some particles. So what are that particles? Particles are nothing but molecules or compounds. In later, we will also discuss about the definitions of molecules and compounds in the next videos also. Okay, so don't worry about the definitions of molecule or compound. Okay, so particles are nothing but molecules or compounds. Now I'm asking question to you again. How the molecules are made up of, or how the compounds are made up of? Think it once again. Yes, they are made up of small particles. So what are that small particles? They are nothing but atoms. They are nothing but atoms. Now today we are going to discuss about the lesson or about the concept of atoms and molecules. So for that purpose we have to know how the atom taking place, how the matter exists in nature, how the matter come into your studies, what is the importance of what is the importance of atom in our life. Everything we have to know, because atom is the basic word related to the everything in the chemistry. Okay, so we have to learn about the atom. Now, see, ancient Indian and Greek philosophers. So many philosophers are there in the world. So in the previously, some Indian philosophers and Greek philosophers, they have some curious questions or curious concepts are there. What are the concepts? Have also wondered why they are wondered about the unknown and unseen form of matter. So they have to know something is there. What are the tiny particles? Means, so molecules are made up of atoms. Atoms are very small particles, but they have to know how they are forming in the form of matter. So they have to divide how the sections are dividing. Just like matter is divided into molecules or compounds, they are again divided into some atoms. So these atoms are again divided or not? They have to know, and they have researched in the long back ago. Okay, so in 19th century, many scientists have curious questions in their minds. Why? Because they have to know they are in front of there something is happening, and they have to know the answers for that situations. So like that some questions are there, we will discuss it. See, our first question is, what happened when we kept a good quality of iron rod outside for so many days or some few many hours or so many months? If you keep a good quality of rod outside for 2 months, so what will happen to that iron rod? And after that, if you wait the good quality of rod before keeping out, and after 2 months, if you weigh the weight of the rod, it may be same or different. They has to know. Okay. And second question is, when we burn a charcoal, we are burning a charcoal to heat something, then at that time charcoal is in the form of solid before burning. After burning, it is evaporating, means its materials are evaporating, and some ash is there at last. So what is happening in that? Is the weight of the charcoal before heating and after heating is same? This type of question. And where does the matter charcoal go? Okay, and wet cloths dry after some time. So when wet cloths are dried for sunlight, what happens to the water? Where that water goes? What is happening to the water? How it is converting into vapors? We have to know. Then what does happen to magnesium on burning it in air? Means this topic is related to burning and combustion reactions. Means if you heat something, after heating, before heating, is the weight of the products are same or not? For example, if you are heating a magnesium ribbon, already we have magnesium ribbon activity in 7th class. In that class only we have some small activity to burn a magnesium ribbon. Okay, students. Now, if you weight the magnesium ribbon before heating, that is the reactant. And after burning, we get some white ash powder. That is the product. If you weigh that product, it is same as the reactant weight. So like this, some curious questions are there to the philosophers to go in this topic very deeply. Okay, students, so they have to know, they have to find the answers for these questions. Are the weights of the reactants or products same or different? Okay, so for that purpose, some scientists are there. They have to keep on research in this regard. Now, I'm showing you about some more examples to understand the introduction of atoms easily. Okay, here, what is this? This is a river. Okay, so how the river is made? Now I am asking question to you. How the river is made? River is made with full of water. So river is made up of full of water, not a glass of water or a drum of water. It is made up of full of water. Now, is river is a matter? Is river is a matter? Yes, definitely it is a matter because it occupies some space and mass in the universe. So entire world means in the world what are the objects, what are the things which are present are considered to be as matter. Now if you take a small glass of water from this river, so here large amount of water is there. Now I am taking a small glass of water from this river. Means I am decreasing the quantity of the water. So it is also considered to be a matter. Now this glass of water is again divided into small drops of water because some drops of water makes a glass of water. Okay. Now here again if you go on inside, again this drop of water is made up of water molecule. So again if we go inside it, how the drop of water is made up of means the drop of water is made by a water molecule. So what is the formula for water? H2O. Okay, so here the drop of water is again divided into tiny particles, means small particles. So each particle means each one is a water molecule. Okay students, so many water molecules has to combine together to form a glass of water. Okay, so only one molecule is not considered to be a glass of water. So many water molecules are there to form a glass of water, and so many glass of waters has to be collected to form a big river, big ocean, etc. Okay. Now introduction. So we have to go on discussing very deeply. Already I have told you that Indian philosophers has made so many researches to find about this matter, about these small particles, about this concept of atom. And who is he? He is a Maharshi Kannad, first Indian philosopher. Okay, gave the idea that matter means in the Kannada it is considered, it is, they are called as padarth. In Telugu also nowadays we are saying some padartham. Like this, matter they are called as padarth. Okay, consists of indivisible units. So if a matter is made up of some molecules, means indivisible units, and that can't be divided, means molecules are made up of atoms, but and that atoms can't be divided further into small particles. So water molecules are made up of water, and if you go on dividing the water molecule, that water molecule can't be divided and it can't make a molecule. That is nothing but atom. Means if you molecules are made up of atoms, means hydrogen and oxygen atoms, and again if you want to divide that hydrogen and oxygen atoms, it can't be divided into small particles. This one says by our philosopher, Indian philosopher Maharshi Kannad. And that small particles they are called as paramanu. What they are calling as paramanu means atom, and it is the smallest particle that can't be destroyed, and retains its original form under all situations. So this is the statement given by our Indian philosopher Maharshi Kannad at the time of 500 BC, means before Christ only they have informed us. Okay, then later on the first proponents of an atomic theory by taking the point of Maharshi Kannad, some Greek philosophers. Who is that? Louis Pus and Democritus. Both are there. They have taken the statement given by Maharshi Kannad and they have researched. And what they say is that matter is made up of small indivisible particles. Indivisible means can't be broken into again. They can't be broken. So matter which is made up of small indivisible particles called atoms. They are saying the same statement given by our Maharshi Kannad. Okay students, so which are indivisible particles are there, we are now calling as atoms. Okay, then at the end of 19th century, scientists were able to differentiate between elements and compounds. Then after the all researchers given by our ancient and Indian philosophers, Greek philosophers, our scientists in the 19th century, now they can get an idea and they can differentiate the particles which are elements and which are compounds, which are molecules, all are things. In that, Antony Laurent Lavoisier and Joseph Louis Proust, these are the main two scientists, gave again in these concept law. Some they have given some laws also based on this concept, and they explain the chemical combination of elements, how the chemicals they are combining with the combination of some elements, how they are combining, all are discussed. Okay, and nowadays these laws are called the law of conservation of mass and law of constant proportion. We will discuss about these laws deeply in further class. Okay, so what we call laws of chemical combinations means here we are adding chemicals to combine or to form another combination. So how many laws are there? Two laws are there. Law of conservation of mass, law of constant proportion. These are the two laws given by our scientists. Who are they? Antony Laurent Lavoisier and Joseph Louis Proust. They have given these laws. Okay, now let us know one by one deeply. Now here a lab activity is there in your textbook also, to find out the change in the mass before and after a chemical reactions. So here we by this activity we are knowing the answers which were asked or which are curious to know the answers of the questions which were discussed in the first slide. Means some questions are there where the charcoal goes after burning, where the water molecules goes after drying, like these questions are there now. So for that questions we get the answers by observing this activity. Okay, let us observe this activity very concentrately. Okay students. Okay.
The law of conservation of mass. In every chemical reaction, the chemical substances react to form new products. The French chemist Antoine Laurent Lavoisier proved that in all chemical reactions, the mass of the substances produced after a chemical reaction is equal to the mass of the reacting substances. Then he proposed a law known as law of conservation of mass. The law says that matter can neither be created nor destroyed in a chemical reaction. The law also tells us that the number of atoms after a chemical reaction will always be the same as the number before the reaction. Our aim here is to verify the law of conservation of mass during a chemical reaction. Materials required: sodium sulfate solution, barium chloride solution, measuring cylinders, 10 ml test tube, thread, 250 ml conical flask, cork, and an electronic balance. Procedure: take the beaker containing sodium sulfate solution. Pour 5 ml of sodium sulfate solution into the measuring cylinder. Transfer it into a 250 ml conical flask. Now, take the beaker containing barium chloride solution. Pour 5 ml of barium chloride solution into a measuring jar. Transfer it into a 10 ml test tube. Take a thread. Tie the test tube using the thread. Hang the test tube in the conical flask carefully so that the solutions do not mix with each other. Take a cork and put the cork on the mouth of the flask so that the thread holding the test tube is held firmly in place. Take the conical flask and carefully weigh the flask on an electronic balance with all the contents, ensuring that the solutions do not mix, and note the reading. Take the flask from the balance, tilt it and swirl the flask so that the barium chloride solution in the test tube spills and mixes with sodium sulfate solution in the flask and forms a white-colored precipitate of barium sulfate BaSO4 and an aqueous solution of sodium chloride NaCl. Wait for 10 minutes to complete the reaction. Take the flask and weigh the contents of the flask again and note down the reading. It will be observed that the total mass of the reactants is equal to the total mass of the products. Hence, the law of conservation of mass is verified. Precautions. When setting up the apparatus and while taking the first reading of the total mass of apparatus and reactants, care must be taken that the barium chloride solution in the test tube does not spill and mix with the sodium sulfate solution in the conical flask. To start the chemical reaction, tilt and swirl the flask well so that the barium chloride solution in the test tube spills and mixes with sodium sulfate solution in the flask. The law of conservation.
So, did you observe the activity very concentrately? Now, what you have understand by this activity? Means, here if you observe it, what are the reactants? Means sodium sulfate and barium chloride they have taken in the activity, and they are measured also. They have weighed. They have taken weight before chemical reaction. And after a chemical reaction, they are also again weighed. They get the same weight. If you observe that one, they get the same weight. See?
Of mass. 150 ml conical flask of barium chloride solution into a weigh the flask on an electronic balance. Wait for 10 minutes mass of the products. Hence, the law of conservation of mass.
Before collusion and after collusion. Sorry, collusion means chemical reaction. So before chemical reaction, the weight of the both substances means sodium chloride and sodium sulfate and barium chloride we have taken, and the weight is 167.400 grams. That is 400. And after chemical reaction, 167.400 same weight is there after chemical reaction also. So by this activity, what we are understanding, if a chemical reaction takes place between the two compounds, between the two compounds, and the mass remains same before and after chemical reaction. So there is no change in the chemical reaction. There is no change in the chemical reaction. Means mass is neither created or nor destroyed in the chemical reactions. So, Anthony Lavoisier, on the basis of this experiment, he states that matter is neither created nor destroyed during a chemical reaction. So, mass is equal, means mass of the products is equal to the mass of the reactants. He proved this one by this activity. So there is no change in the weight of the masses before and after chemical reaction. Okay, students. So I hope you understand this activity. Now, who is he? Now only we discussed. See, Antony Laurent Lavoisier. So he is the father of modern chemistry. He was a French nobleman and chemist central to the 18th century. Keep in mind that he is the father of modern chemistry. Maybe some type quiz questions are there to this one. Okay. So he is the father of modern chemistry. He is a French nobleman. Sorry, he was a French nobleman. Okay. Then chemical revolution and a large influence on both the histories of chemistry and biology. He made a chemical revolution on both the histories of chemicals, means chemistry and a biology. And he is the founder of chemical sciences by establishing two important laws of chemical combination. Already we know these laws. What are that laws? Law of conservation of mass, and we are considered as this activity which we are recently observed. That activity is nothing but law of conservation of mass, and that is the first law of chemical combination. And the second law is law of constant proportion. Okay, students. So already we know that law of conservation of mass by the activity. Let us see deeply. The law of conservation of mass. What is this law? States that the law states that mass of a closed system. So if you observe in that activity, sodium sulfate and barium chloride, we are weighed. How we are weighed? By closing the conical flask by a rubber cork. Means we are weighing the mass, we are weighing the weight of the substances by closing the conical flask. Means in the absence of outer air. That is nothing but closed system. So if you weigh the chemicals in this manner, they remain constant in a chemical reaction also. So in other words, already we know this one, mass neither be created nor be destroyed in a chemical reaction in a closed system. So we have to weigh the substances in a closed system only. So at that time only we got the same values or same weights before and after chemical reaction. And this law was first formulated by our Antony Laurent Lavoisier, who is the father of modern chemistry, in 1789. Okay, students. Okay. Next, who is he? He is the one more scientist. Already we have discussed this name in the previous slide. That is Joseph Louis Proust. So he is the scientists explained about the law of constant proportion. Law of constant proportion. Another law is there to us. Chemical combinations of two laws are there now. First law is given by Anthony Lavoisier, and the next law of constant proportion is given by Joseph Louis Proust. What is that statement? A chemical substance always contain the same elements in a fixed proportion by mass, irrespective of its source. Means if you want to make any compound or a molecule, we have to maintain a fixed proportions. So the fixed proportions has taken important place to made a molecules, compounds. Okay, so this is the important law to made different types of molecules or compounds. So to this, the law of constant proportion is also known as the law of definite proportions. So for this law is called as a definite proportions, means particular proportions are there to make a molecule or compound. Again I am explaining the statement that in a compound, the elements are always present in definite proportion by mass. Okay. Now, already we know the statements. See, compounds are composed of two or more elements, as all of us know. As we already know that compounds are composed of two or more elements. So the proportion in which elements are present in a compound remains the same irrespective of its method of preparation. If you take an example, pure water obtained from any source, means river, lakes, tap, well, any other sources, and from any country, will always contain two hydrogen atoms and one oxygen atom. So if you take the formula of water, the water is made up of hydrogen and oxygen atoms. So they must follow the proportion also. Two hydrogen atoms and one oxygen atom make a molecule, and that molecules are combining to form a water. And this will not change in any way. Okay, and the weight of the hydrogen and oxygen are 1:8 by mass. This will also not change in any way. Like this, the definite proportions are used to make a molecule or compound. Okay, students. Now, who is he? He is also one scientist. Name is John Dalton. Okay. So, what he has given? John Dalton. So, he is 6th September 1766 to 27th July 1844. He was an English chemist, okay, meteorologist and physicist, and John Dalton has given the first scientific theory about atoms. He has the first scientific theory about atoms has given by him. Okay, and he is best known for his work in the development of modern atomic theory and his researches into color blindness. Means he has given some way about the study of modern atomic theory. He said that he said that atom is a solid hard sphere. Okay, so it is a neutral, it has no charge on it. It is a solid sphere. According to him, an atom is a solid sphere that it can't be divided or that it has any charge. See, he has given some more points also. What are that means? According to Dalton, atom is made up of small particles. Like a wall is made up of small bricks. Like that only. An atom is also made up of small particles. Means if you say a matter is made up of small particles, that is molecules or compounds, and that molecules are made up of small tiny particles. Small tiny means we can't see our naked eye. We can't see our naked eye that particles. Even through a normal microscope also we can't see them. That tiny particles, okay, combining to form a molecule. See, if you want to make a wall, we have to create small bricks together. Like that only, if you want to make a molecule, we have to create a group of atoms togetherly. Okay, ma? See here, he has given deep information about the atom by taking some examples also. Here, a bunch of bananas are there. So, already you know that the taste of banana. What is the taste of banana? It is very sweet. Now, if you take a small piece of banana to eat, you have eaten a small piece of banana. And again, I am giving a bigger piece to you. And you have tasted the both. Small piece of banana you also tasted, and the bigger piece of banana also you have tasted. Now I am asking question to you. What is the taste of both bananas? Both pieces of banana. Is the taste same or different? Definitely it is same. There is no change in the taste of banana. Okay, there is no change because a small piece is a part of a big piece. Similarly, if you take a watermelon, no, similarly if you take a small piece and if you take after that you take a big piece, there is no change in the matter of taste. But does the taste of watermelon is same as banana? The particles which are made to the watermelon is same as the particles made by banana? Obviously no. The tastes are different, the particles are different. So both are different. The particles which are made up of watermelon is quite different to the particles made up of banana. Okay. So all atoms of the same element are alike. Means here the proteins and carbohydrates are present in the fruits, we know. But the particles which are made them is different. Okay, students. See here a group of students sitting in a classroom. Okay, just observe the picture. Then here also a group of peoples are there who are sitting in the tea stall or anyway outside. So here there is no a restrictions are there or limit is there to the peoples. Means in a class some up to this students has to be entered, after that no entry is there. There is no restrictions are there, limits are there here. When you come to the cricket team, Indian cricket team, there must be a fixed number. There must be a fixed number. Here in this first one, peoples are also grouped here. Students are grouped. In the tea stall, peoples are grouped. In the cricket team, here peoples are grouped. But here, if you observe, in the first two pictures, there is no limit or restriction is there. But in the case of Indian cricket team, there must be a fixed number. Okay. So here means a fixed proportions are there to make a molecule. Dalton has also explained about this one through normally. Okay. See, compounds are formed when atoms of different elements combine in a fixed proportions. Means here, if you observe in this picture, they are all as compounds. Okay. Here compounds are nothing but they are forming when atoms of different elements, but there must be a fixed proportions. Okay, students. So here two hydrogen atoms. Here again two hydrogen atoms means total 4 hydrogen atoms combine to 2 oxygen atoms to form a water molecules. That is 2 water molecules. To form a compound, there must be a fixed proportions. This was explained by John Dalton. Okay. Now, here one boy is there. He is constructing a wall. Okay. Now, if I have given to you some bricks, cement, marble, granite, and so on materials, and inform you to construct anything, if I have given these materials to the constructor who has a field of construction, then what he do? He construct an apartment or a building and a house by using these materials only. Okay. A Taj Mahal, pyramids, any fort, These are all different structures are made by these materials only. Different structures are there, but the materials are same. Okay, so observe these pictures. These are all different structures, but the basic materials are same. There is no change in the materials. Okay, so according this, by observing this picture, we can say that a chemical reaction involves a rearrangement of atoms. Means here we are constructing different structures by rearranging the materials. Okay, so rearrangement of atoms, not a change in the atoms themselves. Means here we are not changing the material, but we are changing the structures. We are rearranging the structures. Like that, a chemical reaction also involves a rearrangement of atoms, but they are not changing themselves. They are just changing the structures of the molecule, but they are not changing themselves. In the chemical reaction, rearrangement of atoms are happening to form a molecule. Means different structures are forming by the chemical reaction, but they are not changing or vanishing themselves. Okay, students, so this is the basic information to you about the history of atom. Okay, so I think you understand this one. Okay, so make a worksheet. Easy questions are there to you. So according to Dalton, what takes part in a chemical reaction? According to Dalton, you have the answer here. 4 options are there. You have to choose. So what is the law of definite proportion was given by? Who given the law of definite proportions? I have already informed you. Like this, questions are there to you in a simple manner. You can understand it. Okay, very well. If you got any doubts, you can rewatch the video again and you can clear your doubts. Okay, students. So this is the basic concept of math. That is basic concept of atom. So in the next classes we discussed it deeply. Okay. See, total 20 questions are there. You have to answer these questions in your notebook. And you have to show me when the schools are reopened. So must and should make a separate notes for these worksheets. Okay, students? Okay. Thank you.